the previous videos, we mentioned about the practical considerations in terms of the water leakage issue, which you need to provide additional reinforcement bar in order to control the crack width within the concrete, so that the water does not penetrate through the reinforced concrete slabs. We also mentioned that you need to observe the architecture drawing in terms of the intended flow path for the ducting and services, which most likely some beam will require transverse opening to allow this service pipe or air con ducting to pass through the beam within the limited space of the ceilings. Transverse opening can be a structural issue if it is not properly managed. You will need to limit the size of the opening not to exceed 1/3 of the beam height, or preferably it will be 1/4 or 1/5 of the height of the beam. And you have to avoid the opening size at the regions of high shear and high moment. You will need to provide additional reinforcement bar to strengthen the member, as well as to strengthen the opening to prevent the failure of the structural element. The same principles go to the opening on the slab that allows the services to pass through the slab going to another story. Now we will proceed with our discussions through the words that you're going to go through in your assignment. Most likely in your assignment, your lecturer will require you to do the manual calculations, or you may be allowed to create your own Excel spreadsheet for the design. Some students may have the opportunity to use some design software to model the reinforced concrete structure in order to produce the technical drawing for the entire structures. But this most likely is not the case, as from the education perspective, your lecturers are normally more concerned with the theoretical part that you gain through the assignment. Most likely it's going to be either manual calculations or probably with the help of the Excel spreadsheet that you need to go through every single design aspect to demonstrate you really gain understanding on the technical part as you complete your assignment. Excel spreadsheet can be one of a powerful tool to help you with the analysis and design, which you need to create a spreadsheet which is friendly enough for you to resolve a wide variety of the conditions of the member, so that you can do the repeated calculations for different members. In the case that you are doing this Excel spreadsheet, there are a few considerations that you need to take into account. First, it must be user-friendly, and it must be comprehensive to the first-time user. When you design this Excel spreadsheet, most likely it's going to be used by different members in the group to run the analysis for various members throughout the entire building. It needs to be designed in the generic way, covering as much aspect as possible, and for your group members to really know how it is being used. Therefore, it should be user-friendly. And when you produce this Excel spreadsheet, you need to make sure that it is properly and systematically verified. And normally this verification process, it will be through manual calculations. You need to provide evidence that you've done the verifications in your report. The spreadsheet without verifications, it means nothing, as there is high possibility there are some bugs or errors in the calculations. And remember, when you do the verifications, you cannot use the same load case or same loading conditions that was used in the development of the Excel spreadsheet. This may lead to the so-called systematic error, which is you use everything similar. Most likely your manual calculations, which was meant for the verifications, is actually replicating what the spreadsheet is doing. Technically, this is not verifications. That means you will at least require 2 to 3 different load cases under different conditions, which is not repeated from the one that you use in development of the spreadsheet, to cross-check whether your Excel spreadsheet is done correctly. Be careful when you try to repeat the similar calculation steps as you use in the Excel spreadsheet. Or sometimes you can have another group members to verify on behalf of you without providing the details, the basic informations that you use to develop the spreadsheet. Then the verifications will be more objective. Or you may have another member to create his own spreadsheet, and then both of you are to compare the results. Whichever the approach you use for the verifications, as there is no standard way, but the bottom line here is you are not duplicating the potential errors that you have during your development of the Excel spreadsheet. Based on my experience, most of my students prefer to go for the Excel spreadsheet. They have been quite well versed with the usage of the Excel, and they are able to produce quite a powerful spreadsheet. Only that it may not be user-friendly, and normally they are not proper verified, or at least there are no evidence demonstrated how they do the verifications. And there's one more common error from the students, is that they use this graph plotted in the Excel for the bending moment diagram, which normally seems something like this. You know that based on the shapes of the bending moment diagram, this is not the actual shapes. The actual shape of the bending moment diagram, it should be something like this, which you have a sharp spike at the support instead of smooth curve at the support. You will need to have those resolved, or at least you clearly indicate that the bending moment diagram shown in the Excel spreadsheet is just a means to demonstrate the value, but not really demonstrating the actual shape of the bending moment diagram, which at the end of the day, you only refers to the value that you use in your design. Next, let us proceed with our discussions with the design and calculations. As a refresher and to help you to kickstart your assignment, you will need to consider the concrete cover. This can be standardized throughout all the structural elements, which you have the cover for the main structural element like the beam, the slab, the column. They can be of one cover on basis of the exposure class as well as the fire resistance rating. As for the concrete cover for the foundations, especially when there is direct contact with the soil, this it will be depending on the exposure class as well as the nature of the soil, whether there are existence of the groundwater, whether the soil is highly rich in mineral, and so on and so forth. Normally the concrete cover will be thicker as compared to the other structural elements. You will need to also check the surface conditions of the structures in order for you to determine the GK and QK. You will need to refer to EC2 Part 1. Based on the functions of the building, you will be able to determine the QK, which is the variable actions. As for the GK, you will need to look into the descriptions given in the architectural drawing. What kind of materials are being used through some basic calculations in terms of the amount, and you can refer to Eurocode 2 Part 1. In the list of the appendix there are densities of the materials. From there, to some basic calculations, you are able to estimate the GK. Through those estimations, you can choose to slightly round up the number for yourself to have some margins of safety in terms of the loads acting onto the structures, and justify the value that you use. The loadings that you use cannot be any values that you assume, or most of the students, they seek advice from their seniors, what value did they use, and then they use accordingly, without knowing how the values came from. On the education purpose, it is good for you to derive everything from the first principle. Even you have some connections with the industrial people, you may get the exact value that industrial people are using, and most likely they cannot tell you an answer how those values come from. I guess for the learning purpose, you should know all this from the head to the tail. Next, you need to aware that the calculation steps for the beam and slab vary slightly. It is not fully replications in terms of the calculation step, although most part may seem to be similar. This is especially when you deal with the design for the shear resistance. Due to the smaller cross-section of the beam, the calculation step for the shear resistance is normally more tedious, which you really need to check the shear angle between 22 degree to 45 degree. That means definitely the beam sections do not have sufficient resistance by the concrete on the shear. However, the slab normally have a bigger cross sections as compared to the load acting on it. Therefore, the formulas that you use to check for the shear resistance of the slab, it will be different than the beam. There will also be different considerations in terms of the serviceability. For example, the beams are more concerned with the minimum spacing within the beam due to the smaller cross sections of the beam. There will be a minimum spacing between the reinforcement bar in order to allow the concrete to flow through for good compactions of the beam. However, for the slab, it is more concerned with the maximum spacing between the reinforcement bar. As the space are plenty, it is not normal to have reinforcement bar to be quite closely spaced, and the maximum spacing will allow the control of the cracking on the surface of the slab. Next, you need to consider the exposure class, which most likely you're going to expect higher strength and thicker cover for the foundations. We mentioned about this. And also you need to beware of illogical calculations of the loading acting on the columns and foundations. Sometimes, because you did not actually do proper verifications in terms of the calculations, the result may seem to be quite awkward. In fact, there are some quick ways for you to cross-check, for you to have a basic idea whether the calculated result is logical or not. It will be dependent on the degree of spacing between the columns, as well as the estimated areas covered by that respective columns and foundations, that you know that in relative comparison, the magnitude of the load acting onto those members. From there, at least you have an idea whether your calculated result is it logical or not. This happened among our previous students, which they didn't realize that the loading was totally illogical due to some errors of the calculations. In fact, similar things can go for the beams and slabs, which you can compare the result from different members, which is more or less in proportions to the areas to be covered. As you know that normally the loads are given in terms of the areas, such as kilonewton per meter square for both GKs and QK. Therefore, the areas covered by the structural element can be a good reference for you to have an idea in terms of the logical result as calculated from the solutions. You need to mind the one-way and two-way slab. Always check the aspect ratios of the slab, the Ly per Lx. When the Li per Lx ratio is more than 2, that means this is one-way slab, and when it is less than 2, that means it will be two-way slab. Check the maximum and minimum allowable spacing, and be careful, especially for the beam section with limited width such as 150 mm. Sometimes if you have 3 reinforcement bars running in concurrent, there could be limited space for the flow of the concrete during the casting. There is a way for you to increase the spacing between the reinforcement bar which is by increasing the bar size while reducing the numbers of the bar. If you check the tables for the areas of reinforcement bar, 3H12 will have more or less equal area of 2H16. In fact, the rebar areas of 2H16, it is usually slightly bigger than 3H12. With that, by increasing the bar size, you can actually reduce the amount of reinforcement bar. And this principle is applicable for the other size. Let's say you have 3H16. It can be easily converted into 2H20. You increase a size of the rebar and you reduce an unit of the rebar. You can check those from the tables of the areas of the reinforcement bar. By reducing the numbers of reinforcement bar, the spacing becomes bigger, and this will allow you to have better quality of compactions during the casting.